Okay, we're starting Chapter 5 today. Chapter 5 and Chapter 6 continue with probability. We kind of did a little introduction to probability in Chapter 4, and Chapters 5 and 6 expand on that. Chapter 5 is dealing with discrete probability, discrete variables. Chapter 6 is dealing with continuous. If you don't remember the difference between the two, we will discuss those here in a second. In addition to the video, I want you to read these pages 252 through 257. I apologize for the legibility, if you will. For some reason, my pen is not, my little tablet that I use to write isn't working today, and so I had to do that with a mouse. It's a little bit tougher. So, we are going to it's kind of a little bit of review. If you remember a variable you dealt with in different math classes for many years. A variable is just usually a letter that represents some value. Okay, it could represent how tall you are. It could represent how many hot dogs you ate at the baseball game. It could represent how much money you have in your lunch account. A variable could represent many different things. Okay, but it always represents some kind of a value. A random variable is the same, except the random variable part means that it's a variable that's determined by chance. The amount of money that you have in your lunch account is not by chance. You didn't come to school the first day and just by chance some people had $30 and some people had $5 and other people had $12. It wasn't by chance. Okay, random variables are determined by chance. So, for instance, if you roll a die and the variable is what could the value of the die be? It could be a 1, it could be 2, 3, 4, 5, or 6. But each one of those is determined by chance. Okay, so that's the difference between a random variable and just a normal variable. Random variables determined by chance, things that are determined by chance. Okay. Discrete probability distribution. In your reading, I want you to kind of take special note of that. The difference between discrete and continuous, if you forgot this from earlier chapter, discrete are values that can basically be counted. Okay. How many students are in the class? How many cars are in the parking lot? How much money you have in your bank account? That can actually be counted, right, to the nearest cent. Continuous is when you can always, I guess we represented it before, you can always get more and more exact, more and more accurate. Weight is often something that is described as continuous because you can, depending on the scale that you use, you can get more and more accurate. Height, you can get more and more accurate. How many inches of snow fell, you can get more and more accurate. So all of those things, those are examples of continuous. Like I said, that's next chapter. This chapter we're going to be looking at discrete. So discrete probability distribution consists of two things. Values that the random variable can assume, and then the corresponding probabilities. Okay. Some rules about those probabilities, and these have not changed since last chapter, but we just want to go over them again. The sum of all the probabilities of all the events in a sample have to add up to 1. Okay? They all have to add up to 1. Each one of those separate probabilities has to be between 0 and 1. 0 if there's a 0% chance of happening, 1 if there's a 100% chance of happening. Okay. So here's an example of what a probability distribution looks like. The probability distribution for rolling a single die. So remember, probability distribution consists of the values that the random variable can assume. So what are those values for a single die? 1, 2, 3, 4, 5, and 6. And then it also represents or consists of the probabilities of each one of those values. So what's the probability of a 1? The probability of a 2? The probability of a 3? And so on and so on. So it looks something like this. Usually it goes left to right. I guess technically you could go up and down, but a lot of times it's represented left to right. Like I said, I don't really care which one you do. The top should be the values though, or the left-hand side should be the values. And then either the bottom or the right should be the probability. So the outcome here is your random variable, x, and that is a random variable because the values 1, 2, 3, 4, 5, and 6 are based off of chance. Rolling a die is based off of chance. And then the corresponding probability. The probability of rolling a 1 is 1/6, 2, 1/6, they're all 1/6. So that's a very, very basic one. The next one would be represent graphically the probability distribution for the sample space for tossing 3 coins. So graphically is what they want us to do. Before we do that, I want you to find out, or I want to show you how they got these numbers. And again, I told you my little tablet's not working, so I have to do this with the mouse. So think of it this way. We are going to toss 3 coins. So we have the first one, our second one, and our third one. What are the possibilities? The first one could be a head or a tail. The second one could also be a head or a tail. If it was a tail the first time, it could be a head or a tail. If it was a head-head, the third one could be a head or a tail. If it was head-tail, the third one could be a head or a tail. If it was tail-heads, it could be a head or a tail. If it was tail-tail, it could be a head or a tail. We are looking for the number of heads. So how many heads does this have? Number of heads. This is bad. This has got 3 of them. This one's got 1, 2. This one has 2. This one has 1. This one has 2. This is 1. This one's got 1. And this one's got 0. So that's how they came up with these probabilities. The probability there are 8. So that's your possible. 8 different possibilities. How many of them have 0? Only 1. How many of them have 1? 1, 2, 3. How many of them have 2? 1, 2, 3. How many of them have 3? Just this one. So that's where they got these probabilities. Okay. Then they want you to represent this graphically. So, we do this with a simple graph. So our x-axis is the number of heads, and our y-axis represents the probability. Now you could do this by using decimals, 0.1, 0.2, 0.3, 0.4, 0.5, or in this case they're using fractions, 1/8, 2/8, 3/8. Totally up to you. And then we just represent these graphically. Okay. So that is it for this section. Make sure that you write down any questions that you have, and we will see you tomorrow.